Greetings to all. Today we are going to see the isomerism. Definition for isomerism is the isomers or the compounds with the same qualitative and quantitative composition of elements. Therefore, their relative molecular weights and general formulas are identical, but their structures such as sequence of bonding and arrangements of atoms or groups in the space are totally different. This is the main classification of isomerism, constitutional first one, and the second one is the stereoisomerism. Under the constitutional isomerism, we have functional group isomerism, chain isomerism, position isomerism, and under the stereoisomerism, we have optical isomerism and geometrical isomerism. Chain isomerism, when two or more compounds have similar molecular formula but different carbon skeletons, these are referred as a chain isomers, and the phenomena is called as chain isomerism. The example C4H10, which has two different structure. First one is N-butane and the second one is 2-methyl-propane. Position isomerism, when two or more compounds differ in the position of substituent atom or functional group on the carbon skeleton, they are called position isomers, and this phenomena is termed as position isomerism. The first example is 1-butane and with 2-butane. Here the triple bond attached at the first carbon in the 1-butane and the triple bond attached in the second carbon of the 2-butane, and this is known as position isomerism. And the second one, the second example, 1-propanol and with 2-propanol. The alcohol, the functional group attached at the first carbon in 1-propanol, and the OH, the hydroxyl group attached at the second carbon at the 2-propanol. Functional group isomers, the two or more compounds having the same molecular formula but different functional groups are called functional isomers, and this phenomenon is termed as functional group isomerism. The first example with propanol and propanone. The first one is with aldehyde and the second one is with ketone. So the second one also propanol and propanone, and the third one is with 1-propanol and ethyl methyl ether. So the examples with alcohol as well as the ether is compared here at the third example, but the molecular formula is only C3H8 and O. The stereoisomerism, it is the existence of compounds whose structure differ from each other only in the orientation of bonds in the three-dimensional space. Stereoisomers have the same structure formula, they have the same connectivity, their constituent atoms are connected in the same order but different in the manner in which atoms or groups have arranged in three-dimensional space. Therefore, their structure cannot be superimposed on each other even though they have the same molecular and structural formulae. The geometrical isomerism is having the criteria like two atoms or groups attached to each carbon of the double bond should be different. For example, here cis-2-butene and trans-2-butene. The first one, if you see, the 2-methyl group at the same position, the identical sides of the carbon atoms, but in the trans position, the opposite of each other is there. So the cis is the identical position and the trans is the opposite position. This is the geometrical isomers. But even though if you see the molecular formula of cis-2-butene and trans-2-butene are same, but the arrangement of the atom in the space is only differ. So these are all the references. Thank you.